No, it's coming, I think. There we go. Yes, it's visible now. If you want to make it full screen, yeah, great.
Is this visible now?
Yes, it is. It's not full screen yet, slideshow, but this should be able to work. So go ahead.
Okay. So hello everyone. Good evening for the people in US and good morning for the people in India. I am Kripa Tiwari, PhD scholar from IIT Delhi, presenting my work on the topic integration of pico hydropower, solar photovoltaic, battery energy storage based renewable energy sources with dual mode operation. And this work is done under the supervision of Professor Bhim Singh, IIT Delhi. So these are the contents I'll be going through, starting from the introduction, then moving to the motivation of this topic.
We're still seeing your first slide. Can you?
Is it slow? It is not visible. Outlines.
We can see your first slide. We can't see the second slide. I don't know if you can click on the second slide.
I'm already on the second slide. I'm sorry for that, but I think
maybe we're not seeing your full screen aspect. So maybe we're seeing. Do you have multiple screens?
Yes, you can try
the
again.
Second slide.
No, you still see the first slide. So why don't you try reshare it again? Just disconnect and then reshare it again.
Yeah. I am just stop sharing and then I'll share again.
Yep.
I'm sorry for that.
That's fine. Yeah.
Also, I have mailed you. If you could open them, I have mailed the slides also.
Are you've emailed them or you uploaded them? Let me see if I can get them in.
I have tried sharing once more. Is it visible now?
Yeah, it's visible now. We can see the second slide.
Yep, it's okay, much better. Thank you.
Okay, then these are the outlines I'll be going through, starting from the introduction, then I'll be moving towards the motivation, then configuration of the system and the control strategy, along with the resultant discussion, conclusion, and then references. So starting with the introduction, if we talk about India is the world third largest consumer of electricity, and the target of producing 175 gigawatt by 2022, 500 gigawatt by 2030 from the renewable is the target of the country, which has to be achieved. So the best possible way is distributed energy resources based power generation. It is to expand the energy supply while also reducing the environmental impacts. So the concept of integration of distributed energy systems, which is intelligently controlled and also smartly manages the interconnected loads and distributed energy resources capable of operating in parallel with or without the existing utility grid, is adapted in this work. So coming to the renewable energy sources, pico hydro generation energy systems as a very small scale infrastructure designed to generate electric power by the converter.
Yeah, we still see the second slide. Yeah, we didn't see any movement in the slides. So we still see the slide number 2 outline.
Now?
Yeah, we still yeah, now it is, we can see the introduction. Yes.
So I may not move to the slideshow mode. I think that's the problem with that. I think I'll go with this mode only.
Yeah, this is completely fine.
Now the introduction is visible, right?
Correct. Yes.
Okay, thank you. I'm sorry for that. But among renewable energy sources, pico hydro generation energy systems and has ability to complement with the photovoltaic array source to form a microgrid along with the energy storage, as we'll be moving from grid connected mode to islanded mode. So battery energy storage plays an important role. So I think I am not repeating this introduction. I'll be moving towards the motivation of this work. So the motivation of this work comes from the advantages of the sources present here, and also the machines used for the generation of picohydro power as and MPPT algorithms, which are used for the extracting the maximum power from the picohydro as well as from the solar, as both are intermittent in nature. As in this case, I have used a brushless DC generation. So advantages are that it does not encounter the problem of people's displacement, and also its installation is cheaper than solar and wind. But as we come, the hydro turbines are basically slow speeds turbine, which are directly coupled with the high efficient slow speed generators. But among all generators, permanent magnet brushless generators have find this gap in coming years, as it's an appropriate options to harness with lesser environmental effect and also with the variable speed operation. Also, it is giving the DC power as an output, so the problem related to voltage and frequency makes is independent. And the brushless DC generator, the current without mechanical commutator makes it more efficient and compact in size, and also less maintenance required used for picohydro generator. The variable power produced by variation in the flowing water can be harnessed. The variation can depends on the seasonal variation is considered here, not like as the irradiance which keep changing is a day in case of solar. So here the seasonal variation taken place. So major benefits of these are that the reduced noise with reduced vibration on the turbines, and also high dynamic response of the system. So these components from the generating DC power from the hydro source in connection of PMBLDC connected to through a diode bridge rectifier and a boost converter to step up the power to the DC link. So this generated voltage is proportional to the speed of the generator. So and also the speed of generator is dependent on the variation in the flowing of water. So the trapezoidal EMF wave shape of the generator also decreases the manufacturing cost of the magnets, and also the power density increases. So basically this machine finds its gap better than the other machine which are connected at the AC terminals or the point of common coupling. So this is connected at the DC coupling, DC side of the system, which makes this also independent of frequency and voltage variations. Also, the motivation regarding the solar photovoltaic base generation is already, we all know, it's clean, silent, abundance in nature, also reduce maintenance. The conventional MPPT algorithm is used in both the cases, in case of solar also and in case of hydro also, for extracting the maximum power, because it is easily to implement for uniform variation in case of radiance and in case of variation in rate of change of water. So in case of uniform radiation, we can go with this MPPT algorithm. Also, a battery is connected using a DC-DC converter, which is buck boost converter, to maintain the DC link voltage and also to manage the power flow in the system. And also the converter suppresses the second harmonic component in the system. So if we move to the system configuration, I hope the system configuration slide is visible.
Yes, we can see it.
Just to confirm. Thank you. So this is the system configuration. As we can see here that solar photovoltaic array is directly connected using a single stage configuration, and a BLDC based hydro turbine is connected using a diode rectifier and a boost converter. So this boost converter design is very crucial, as we know that the output current of the diode rectifier is not very smooth. So we have to, this inductor design is crucial in this case. A bidirectional converter is connected through a battery and at the DC link terminals. So this is acting as a storage and also maintaining the DC link voltage in case of system. This is also plays a crucial role in case of islanded system. And this 3-leg VHC is connected using an interface connected to a grid. And these solid state switches are used to make the system connect and disconnect to grid and islanded mode. These non-linear loads are connected, which we have to feed it every time, irrespective of the mode of operation. These ripple filters are designed to suppress the switching transients at the point of common coupling, and also at the switching losses produced due to the converter. And this is the grid. So here single stage operation has its own advantages, as the converter is missing in this case, so the losses and the cost also reduces. So this is the system rating and design of the system we have done using DC bus voltage, how the DC voltage, capacitance and AC inductance are measured. Also the voltage ratings of the converter what we have chosen in this case. This is the 3-phase 230 volt 50 hertz grid we have taken. Also the solar characteristic is used using a PV emulator. This BLDC based generator is rating is around 4.34 kilowatt with a battery of 42 amperes, and ripple filter it designed using the frequencies, and non-linear load or diode rectifier using RL load is used. A DC link PI regulation and control parameters are given in this slide. So this is the basic control strategy used in the grid tied mode. So in grid tied mode, what we have done is we have taken a SOGI FLL, which is the improved version, as because we know that there might be a DC offset or noise or present in the system due to the unbalancing or present of nonlinear load in the system. So we have used this FLL algorithm for estimation of the weight component of the 3 phases, and also a feed forward term is used to improve the dynamic response of the system, which is PV feed forward term in this case, and also the feed forward term of hydro is also used in this case to increase the dynamic response. As we know, we have to move the power from source to the load and to the grid, so we have to use this PV feed forward terms, and this is the controller for the bidirectional operation. So as we know, the reference DC link is now maintained using the bidirectional converter in the system, and the reference is generated using the single stage conversion of the PV. So in this case, we have seen that, and once the all the weight component is calculated, then a reference, the overall weight is calculated and it is multiplied using a unit template to generate a reference grid current. So these reference grid current is compared with the sense grid current, and all the mathematics is given in the next slide. So these grid currents are compared with the sense grid currents to generate the pulses for the voltage source converter in case of grid tied mode. So these are the control strategy mathematics. As we can see, the conversion of sense line voltage into phase voltage has been using these formulas, and the magnitude of terminal voltage, which is as the PCC, is calculated using this, and a unit template is generated, and which is multiplied with the overall weight component to generate the reference current for the grid tied mode conversion system. So this is the basic structure we have used for the extracting the fundamental component of the grid current. So in this case, we have improved the SOGI FLL algorithm, where we can see that this is the part where the frequency loop is using a gain and an integrator, and here we know that the this is second order generalized integrator, and we have implemented as low pass filter and a gain to in the quadrature component, just to remove the DC offset and the noise present in the load component. So this precisely works, as we can see the comparative analysis in the coming slides, that this is capable of generating this is capable of removing the noise in the DC offset in the system. So this is the basically how we have average component of weight component is calculated here, all the 3 phases, and the feed forward component is calculated using these in both cases of solar as well as hydro, and this overall total weight component, which is used for generation of the reference grid current in case of grid tied mode. And here we can see that the control of DC-DC buck boost converter, which is connected at the DC link terminal via between the battery and the DC link terminal. So we can see that the outer loop and inner loop concept is used here. The outer loop to use for the DC link voltage regulation, and the outer loop PIs generate the reference current, which will differentiate the battery charging and discharging mode. So this is the equation that we have used for. Also the KP and KI of this design using the Bode plot analysis. So we have done that, and this is the inner loop for the current control, and we can see that the duty cycle generation of battery buck boost converter can be deduced here. So this is basically the control strategy in case of standalone mode. So we can see that the transition takes place from standalone mode to grid connected mode, or from grid connected mode to standalone mode, using this synchronization control. So this control is very crucial to this the value which is given to static switches, that either 1 or 0 logic. If with the 1, the system is connected to grid connected mode, and if the logic 0, then the system is disconnected from the grid. So these are the few parameters which we have kept in mind. So basically the main parameter is the phase error minimization, which we see using this phase error minimization loop. As we can see here, the phase angle of the load voltages and the grid voltages have been minimized using this, and the new theta which is used is now the new theta which is going to be used for the giving the voltage generation, or what we can say that the terminal voltage for the system in case of grid standalone mode. This terminal voltage is the voltage around the point of common coupling. So this a constant voltage is multiplied with this new theta generated sine waves, and a reference load voltage is created in case of grid in case of standalone mode. So here grid is not present, so the voltage reference will be the constant multiplied with the sine values, and the reference load voltage will compared with the sensor load voltage, and here also the PI controller is used to obtain the reference load current, which is passed through into hysteresis controller for generating the pulses for the voltage source converter in case of standalone mode. So these are the synchronization control in which 3 criteria has been taken place: the frequency, voltage, and the theta, which is the angle. And also you can see that in case of standalone mode, the control of bidirectional converter is very important. So because in this case the battery plays an important role, but in case of grid connect standalone mode control strategy, as we can see that the line voltages of common point type of common coupling are sensed, and using this they are converted into phase voltages. And this is the generation of reference voltages, load where 3 phase sine voltages of nominal frequency, where we have taken the frequency around grid frequency in India is around 50 hertz. So we have taken that in this case, and this is the terminal voltage, which is 230 volt upon 2 by root 2, which is the terminal voltage in this case. And this is the reference of all the 3 phases are not shown here. For the single phase I have shown here that how the reference load current is generated using the PI controller. And this is the synchronization control loop. So we can see that during standalone mode, the angular frequency error is generated, and a phase error minimization is used to generate the new updated angular frequency, so as to change the logic of the AND gate, which is from 0 to 1 or whatever from 1 to 0. And then operating mode also shifts from standalone to grid tied or grid tied to standalone. So the output of the PI controller or the phase error minimization loop is used using this PI controller, and the updated phase angle is calculated as the theta nu and the sampling time with the difference between the frequency. So this is the simulation results what we have done in the grid tied mode and standard mode, and also the grid current THD is shown here. Also the experimental analysis is done in the next slides. So we can see that in case of standard mode, it is very important to maintain the voltage at the point of common coupling. So converter control is capable of doing that. And also we can see that in case of grid tied mode, the battery is almost having a 300 watts, which is around the loss of the system. But in case of standalone mode, we can see that the grid power is 0 as grid is not present in the system. Rest other parameters, in this case, the battery is taking care of the power which was previously fed into the grid in case of grid tied mode. So here we have taken few dynamics results also in case of grid tied mode, as we can see that the load unbalance and the PV on, and as we have 2 sources and both are intermittent in nature. So figure 2 shows the intermittency of the sources in this case, and how the grid tied mode, the grid is capable of taking care of that intermittency, which is shown in the figure from the waveform 4th, that if the power of the source is reduced, the grid is changes its direction to feed the load, irrespective of change in the dynamics. In case of sources or loads, load is the converter is capable of feeding the load all the time. So in this case, we can see that also as the load is disconnected, the grid current is increased, and the VSC is capable of compensation. As we can see that the VSC waveform is changes becomes the sinusoidal of that own phase, and also the load is disconnected, the load power is decreased, but that the power which was previously feeding to load is now fed to start feeding to grid, so we can see that grid power increase. And in this case also we can see the two conditions where the rate of flowing water is decreased. At that case also the grid is capable of taking care, and when the PVA disconnection takes place, even if the one of the source get disconnected, then also grid is also and the battery is also present in the system capable of taking the and this is the system dynamic performance during the seamless transition between the operating mode. And it is very evident from this figure that the grid disconnection takes place at the time t is equals to 0.4. So during the grid disconnection, the grid current becomes 0, but the voltage at the point of common coupling is maintained to its position because the converter control is suddenly shifted from the grid connected mode to standalone mode, and we can see that the battery starts acting as it's becoming the charging direction. Whatever power was previously feeding to the grid is not fed to the battery. And these last four waveforms are very important in this case because these are the synchronization signals. As we can see that the error becomes 0 after few cycles, and as we move from the grid reconnection mode, the error of the phase angle minimization what we have seen in the previous slide in the control slide, that this starts acting, and as soon as all the three conditions become one, the system moves from the grid type. Even if the voltage appears, the current will appear after few cycles. So in this case we can see, and this is all justified in the case of experimental analysis also. So these are the experimental analysis we can see in the grid connected mode. These are the and also as PV current increases, the power, as we have feed forward term in the system, the power is start feeding to the grid. And in second case, we can see that the hydro but load is commonly fed all the time. And in third case, the load removal, non-linear load removal, then also the grid power increases. And in case of the standalone mode also we can see, then standalone mode, the basic importance is the VLA, that is the load voltage, and also the DC link maintained in the second figure. And then also the third figure, we can see that the load is feeding irrespective of the modes of transition, and the DC link is maintained to its nominal value, which is 400 volts in this case. And this is the transition. We can see that how the system moves from grid connected to standalone mode, and how battery starts discharging in case of standalone mode, and the load components are maintained to its nominal values. And in this case also we can see that the how system is moved from standalone mode to grid connector mode, how grid current appears after a few cycles, and the system is maintained to it, the load voltage especially, which is at the voltage at the point of common coupling, it's maintained to its nominal value. This is the comparative analysis of control. What we have seen that the improved SOGI FLL and SOGI PLL and SOGI FLL, we can see that the steady state error as well as the convergence time is also less compared to other two algorithm when there is noise and DC offset present in the system. So this system is taken care under these effects in case of noise and DC offset in the load current. And this is the conclusion where we can see that it is capable of harnessing the PH power using the BLDC generator, and because it is independent of frequency and voltage generation, unlike AC generator, as AC generators are connected at the points of common coupling, so whatever happens at that end will affect the performance of the generator. But in this case, as it is connected at the DC terminals of the system, so there will not be any effect of this variation frequency variations. And also VSC is capable of maintaining and rejecting the noise and DC offset present in the system, and also advantages like fast convergence and lesser steady state error. These are the references used for this work. Thank you. If you have any query, you can ask.
Thank you. So I don't have any questions in the chat. Does anybody want to unmute and raise a question? Any questions? Oops. There was a question about sharing the PowerPoint. I don't know if you can share that in the chat.
Oh, I'll try. Otherwise, I have mailed you. I'll try to share this in the chat.
All right.
But Schultz, I have a question.
Okay, go ahead.
Do we have to share everyone the slides on the chat, or is just for?
I think someone was just asking for these slides. I think that's really up to the author. If they want to do a PDF and upload it, they can do that. But the presenters can decide if they want to share their slides or not.
Okay, understood. Thank you so much.
Yeah. And you can also upload it to the link I gave you and let me know if you want them shared or not. And we can share those internally. The videos are going to be provided externally, so to be shared with that. So, all right. All right, so let me, I'm going to share with you the PowerPoint here. Okay, so thank you for being on. This is the end of session 3. We appreciate everyone participating. In about 10 hours, we will start session 4, where we have 2 other talks on theme 4, as well as several talks on theme 5, which include microgrid, advanced distribution systems, and cybersecurity. And so you can see those talks tomorrow in about 10 hours. So for our colleagues in India, we wish you a great Wednesday. And for those of you in the US, we wish you a great evening, and we hope to see you in the US morning. So thanks everybody for participating. Thanks for our 4 speakers. And we look forward to seeing everybody in session number 4. Thank you.
Thank you all, and thank you, Noel, for your persistence. 10 hours.